Math is a language. It is an abstract language, and algebra is perhaps the simplest of the languages. And you have abstract symbols. You have X for something that's unknown. If you have two unknowns, you have X and a Y. I use the same idea. I do a figure called 10 men, which is done fairly simply. It is the one that I teach second to my new students. And there it is. And since it's a web, it lends itself to permutations, changes. So what I have done is that I've looked at the procedural way of making it, which is operations. This is an operation. So let's call it A. It doesn't have to have a name. It can be called number 1. It can be called X, Y, Z. It can be called anything. Just A is the simplest. If I pull that string again and down flip it and put it in the system, it erases the A. So that down flipping is the inverse. And once you have a system which has an identity element, which is the loom, clearly defined operations, A and their inverses, A prime, which when done in sequence will get you back to the identity element, you have what is called a group. And group theory is one of the most powerful of the modern mathematics. And of course, there's the A, under with the far is the B, over the far is a C, push the near under, and then over is a D, and over and then under. Come on, fingers. Okay, you see, it really does take concentration and practice. There's the E, and of course I can down flip the E for the E prime. And again, put up, say, an A. So this is an E prime A, and it doesn't look like much, but it is entirely within that system. And since you have 10 elements, the 2 weave patterns is 10 squared is 100 different patterns. 3 weaves is 1,000 different patterns. 4 weaves is 10,000 different patterns. And so you can see that you can do these forever in the 10-men system and never get to the end of them. I do 10, 11, 12 weave patterns, and I've learned how to make them so that they are open enough that you can open them.
Okay.